Good afternoon to one and all. Today we will discuss on the topic measures of dispersion. So previous classes we have discussed about that measures of central tendencies. So what are there in the central tendencies? Mean, median, mode, and geometry mean and harmony mean. So these are the tools which we can use to study that averages and which is the middle value and which is a highest repeated time, which is repeated again and again. That we have studied about. But when we have the certain data, so there is some variations, there is some dispersion, there is some dispersions. Yeah, see, we have discussed about that averages and median and mode. So for example, when we have the data set, when we have the data, so there is some dispersions, nothing but there is some variation from person to person and particular data set to another data set. For example, if you take into account, so in our BA classes, so there are some two groups. For example, EPP and HEP. For example, if you take EPP and HEP, there is a different courses. So, for example, if I want to know that how many marks scored by in particular EPP and how much scored by HEP students. For example, if you take it over two groups, so within the two groups, if I want to know that how much marks scored in the particular subject. So among the students, so there is some variability that is called the dispersions. So in order to know that how much dispersion is there, so even when the mean value, the average is same between the two persons. Okay, so that we can do it. So today we will discuss about measures of dispersion. So, see, in the introduction part, for example, what is meant by measures of dispersion? So, dispersion is nothing but variability or variation. Simple, we can say that dispersion is nothing but variability or variations. So, the variability is an important consideration of statistical description and a basic concept in statistical inferences. For example, when you draw some conclusions, some inferences, some results from the particular data set, then we need to know that whether there is any variation or is there any variability in the particular data series. Then we need to find out. And that is the thing that the variability is a very important consideration in the statistical description, and it is a basic concept in the statistical inferences. Inference is nothing but whatever we get some results, that inferences. And a measure of variation or dispersion, we can say in shortcut, we can say MD. MD nothing but measures of dispersion or measures of variation. In any data shows the extent to which numerical values tend to be spread about an average. For example, if you take into account when you are calculating the averages about the two persons in a particular class, some people the average will be same, but there should be some variations. Sometimes there may not be variation, but we need to know that which person has maintained a consistency in all the subjects and which person has not maintained the consistency or the variation. That kind of thing we need to show, and we need to learn that how much extent to which the numerical values tend to be spread about the average. For example, see that, so here the tend to be spread about an average. It's nothing but an average, how much the each and every value or observation is tend to be spread. Nothing but how much is spreading from the average value. That should be we need to learn in the measures of dispersion. The measures of dispersion can shows that how much the spread, how much is spreading from the mean value. That is the average value. Then we can learn. And the different series may process the different dispersions. For example, if you take into account when we have the different set of data, then the series may process different dispersions of items around the mean, around the average also, around the average. For example, if you take into account when you have the take the two data series, so one data series may have that there's a different dispersion, and other series they have a different dispersion. Nothing but so which is very close to the average, which is very close to the mean value. That should be good. Then we can come to know that in the statistical practice, we can come to know that. And we may not know this by merely simple, we can simply looking at the averages. For example, if you take into account when you calculate the averages, the both person will get the same average, but we cannot come to know that which person is good, which person is not good. or which person has maintained the consistency and which person is not maintained the consistency. That is a main thing. That is, we cannot come to know that without studying the dispersion, especially if they happen to be identical. For example, sometimes when the mean value is very same, mean value is very same to the two persons. So I'm going to show that how it can be happen. See the next slide. See, for example, if you take into account the BA section, that is the subject we have taken, the economy, polity, and public administration. See, when the main papers in the BA section, for example, if you take the marks of Beam or the marks of Ravan, there are two persons who are studying in the BA. So they got see. So the Beam has got 53 marks in the economics, and he got 55 in the polity, and he got 57 in the public administration. And the Ravan, who has scored 88 in the economics, and Ravan scored 42 in the polity, and the Ravan scored 35 in the public administration. For example, when you calculate the total 165 and 165, the Beam and Ravan. So who is the first? Can anybody can guess? So on the base of total marks, so both are equal. When you calculate average, the average also same. See, 155 divided by 3. I think, is it right or wrong? 165 divided by 3. 55. So the average value is 55. See, on the base of average value, who is the best person? Can anybody can say that? Hello? Hello, dear students. You can respond. You can unmute and respond.
Both are equal.
Both are equal. See, when data is like that, what we can do? That is the main question. Yeah, please. Please respond. You are there. Niharika or Durga Prasad, Somnath, Usha Sri. See, when we have the data like this, for example, so the marks of Beam, the Beam marks 50, 53, 55, 57, and Ravan marks 88, 42, 35. So when you calculate the total, so both are equal marks. They got equal marks. Though we cannot decide that who is the best one. Then, see, when we are calculating the averages, for example, we want to show that we want to say that on the basis of average. For example, if we calculate the average also, the sum of total marks by number of papers. So 165, 3, 55, he got also 55. So on the base of average also, we cannot say that who is the best. Then when we have this kind of data set, we will come to know that which person who has got minimum variance, or who has maintained the consistency, so that on the base of the consistency, on the variation, we can say that the person is a good, the person is not good. So see, when you observe the dispersion, nothing but variation, nothing but, see, when the person has maintained the consistency, nothing but in the economics he has scored 53, the polity has maintained the 55, the public has maintained the 57. See, when we calculate the average 55, the 55 is very close to these 3 marks: the economics marks, polity marks, and public administration marks. So when if you take into account Ravan, see, he got average marks is 55. So here his marks are higher than the average, and which are very close to that polity marks of average. See, the polity marks is 42 and his average is 55. So there is a close. But whereas come to the public administration subject, so he has scored only 35, but his average is 55. See, so when comes to the Ravan, so he has not maintained the consistency in the marks, because he's not able to get the marks to the average. He has maintained good, he has scored good marks in the economics, but whereas come to the public administration, he has not scored well. But whereas Beam, so he has scored an average, the good marks for the an average. So here we can conclude that the Beam has maintained a consistency. Consistency, nothing but we want to maintain the stability, or stability or regularity or uniformly. Okay, that for example, if you take into account your marks also, for example, if I conduct a test in the 1 week, for example, the first day, second day, third day, fifth day, like that. So if you maintain the consistency, 10 marks, 11, 12, 13, 14, 15, so you may get average is 12, that is you are good. But in a first day, if you get 1 mark, in the third day you may get 15, and the fourth day you may get 10. If you get in the next day, you may get 13. If you get 2, so in that meanwhile, when you are calculating the average, you may get, you are not maintain the consistent. You may get around 6 or 7 average value, but you may not maintain the consistency to get the marks. Okay, so that is the thing that we can study the measures of dispersion. Is it clear, or shall I explain another example? Hello, dear students.
It's clear, sir.
Yeah. So if you are not able to understand, I will give the best example for that. Another example. For example, if you take the cricket match. So if you assume that the subjects are the match 1, match 2, match 3. For example, if you take in earlier, if you take beam as a Sevak, for example, here, if instead of beam, you can put Sevak. So sometimes Sevak scored on 100, 0, duck out, another once he will get 10 score also. So meanwhile, in the 3 matches, he has not maintained the consistency, because in match 1 he may scored he might have scored 100. In the second match he may have duck out, and the third match he may have duck out he may have scored 10 runs. So meanwhile, when you are compare that other persons, for example, if you take instead of Raman, you can take the Dhoni. So here if he has done 50 half century. In the next match he may have done 60. In the next third match he may have done 55. So in the 3 matches, what we have to do, we can estimate that in the 4th match he may scored around 50 runs. We have the some capable, nothing but in the previous matches he has scored good score, that is the 50, 60, 70, and we can expect that in the next match also he may scored around 50 or 60. But whereas in the 7, we don't have the confidence to say that he may scored 100, he may duck out also, like that. So the Sevak didn't maintain the consistency. When you observe some matches, the Sevak didn't maintain the consistency. That is a thing that we need to study, the dispersion and variation. And before when we are studying that MCT, measures of central tendency, is that average of the first order. Average of the first order. Nothing but when the data set is given in a particular research area or particular problem, so we will calculate the average. So on the base of average, we can say that. For example, when the average of the 2 people is same, we will go to the second one. That's the measures of dispersion. That's it called measures of dispersion is the second order. MCD is the average of first order, and MD is the measures of average of the second order. Then, as we discussed, that arithmetic means are identical. Identical, nothing but same. Whatever we have shown in the last year, arithmetic mean is same. That is identical. But variation in the performance of 2 students are large. 2 students are large. The variation is very high between, see, when you observe this 53 to 55, how much the variation is only 2. The difference is only 2. Here, difference is 2. But whereas it comes to that Ravan, 88 and 42, there is a large difference between the 2 marks. See, around 46. Here, if you take, there is how much the difference? So around 7. See, this is the variations. So the variation in the performance of 2 students are large. And here, MD, there is a measures of dispersion, gives an idea about extent of lack of uniformity or uniformly. Lack of uniformity. Nothing but, so the measures of dispersion can give us an idea about that the extent of lack of uniformity. Nothing but how much lack of uniformity in the marks. You can come to know that this is the lack of uniformity. Nothing but how much you scored. For example, if you take into account your marks also, for example, if I'm going to give, for example, if you take into account in the intermediate 10th level and intermediate level and degree level, and so how much you maintain the score. Nothing but if you take into account percentage also, you may think in the 10th class you might have scored 80%. If you maintain 80%, it is good in the intermediate. But if you maintain 90 also, no problem. But if you maintain if you have maintained around 50% or 40%, it is not a good. There is a variation is high. There is a you are not maintaining uniformly. That is the case that measures of dispersion, which will give an idea the extent of lack of uniformly, the sizes and the qualities of the items in the series also. For example, when you take into account the quality of the service. For example, when the B companies will do some surveys on the MCOM, the marketing field. For example, some people will give the quality assurance. For example, if you are using the mobile wallet, for example, if you take into account payment wallet as Google Pay or Phone Pay. So if I have the question to the today, so which how many score you can give to the particular payment app from 1 to 10 score. So you may give the 8 today. For example, if the tomorrow you may not the payment apps may not work properly. So if I ask tomorrow also the question, so you maybe give less than 8, and next day after next, some people may give best one nothing, but you may give the best out of 10 to 10. Here means there is a quality of the items. For example, on the base of the service which are provided by the networks, so we will give the some ratings to the particular services. So on the base of in the qualities of the items also we can measure the variability, and the MD, the measures of dispersion, helps us to know the degree of uniformly and consistency. So simple as we have discussed that the MD, which can help us to know that how much the degree of uniformly is there. Think about how much the degree of uniformity has maintained the particular person or particular service or particular network. Then that much of degree of uniformly we can come to know that how much the degree of uniformly maintained by the particular network. For example, if you take into account the marketing field of the network of mobiles, or if you take into account Airtel, Idea, or Geo, for example, you may either give the ratings for the particular to the networks. So on the base of the network ratings, we will come to know that which network is provided good services to the people. There is a degree of uniformity and consistency. For example, if you take into account when you are using particular mobile, particular network. So if the network is good and signal is good and with the data is very speed, that each and every day the network is provided same thing. So that network is provided the the network has maintained the consistency in the providing services to the public. So that is the main thing that we can come to know that by using measures of dispersion. Okay, is it clear that about measures of dispersion introduction part? Hello, dear students.
Yes, sir.
Yeah. Okay, I will go for the next slide. Yeah, this is the next point, which is very important. That if the difference between items is large, for example, if you take into account when you are calculating that difference between the items is nothing but values of the particular variable. That if the difference between between items is large, the dispersion or variation is large. For example, if you take into account, as I told you that in the BA, in the first year, for example, if I am scored in the first semester, second semester, for example, if the difference is between the two semester marks is very high, the average variation also very high. For example, during the first semester, you may have get out of 100, 60. In the second semester, you might have get that around 80. The difference is 20. Okay. So, for example, if another person, if you take into account your friend, in the first semester, he might get 70. In the next semester, the second semester, he might have got that around 80 marks. The difference is high in the your marks, and the difference is very less in the your friend marks. So you got 60 and 80, and your friend has got 70 and 80. The difference is very high in your marks, but whereas come to your friend, the difference is very less. That is the thing that when the difference between the two items, that the two values of the two observations is large, the dispersion or the variation is large. and vice versa. If the dispersion is the difference between the two values or two observation is very less, the variation is very less. Okay. So the one question will ask the in the computer exam also. For example, if the variance is less, the person is good or the service is good. If the variation is less, the person is good or the service is good. We can say that on the basis of marks of the student, we can say that the variation is very less, the person is good, and he has maintained the consistency. For example, if the person has got maintained the if the person has got marks or the in the marks also there is a same, he has maintained the large difference. So we can say that the person is not good and he has not maintained the consistency or inconsistency. Okay, and the dispersion is very high. See, and for example, when it comes to that measures of dispersion, how many types are there? So basically, in the statistically, we can say that there are two types of dispersions. There are two types of dispersion. First one is the absolute dispersion, and second one is the relative dispersion. What is mean by absolute dispersion, and what is mean by relative dispersion? First one, the absolute dispersion, when the dispersion is measured in terms of original units of the series. For example, original unit nothing but whatever we are going to collect the information, that information should be in the original or that original units. For example, if I ask the mark about your marks, if you say the out of 100, 60, that 60 is the original value, the original unit of the series. So when you are taking such kind of data, if you calculate the dispersion, that is called absolute dispersion. Absolute dispersion. And also when we are going to show the results in the terms of original values, we can say that not ratios and not percentage. We can say also that absolute dispersion. So mainly the absolute dispersion nothing but when the dispersion is measured in the terms of original units of the series. It is called absolute dispersion. And what is the relative dispersion? The relative dispersion nothing but the variation is in the form of ratios or percentage. For example, when we are calculating the dispersion, so as I told that if I collect the information about the marks of the particular students, boys and girls, for example, if you take the girls and boys separate, how many scored in the particular economic subject, if I calculate the variation, and how much scored by the boys, separate boys and girls. There are separate two groups, for example, boys and girls. So if I calculate on the base of your marks, if I show in the form of ratios or in the form of percentage, that is called relative dispersion. Relative dispersion. The variation in the form of a ratio or percentage is called the relative dispersion and is independent of original units. So whatever you are going to show or whatever you are going to express, the dispersion, it is an independent of original units. We are taking the inferences or we are drawing the inferences from the original units only. Original units only. And it is useful in the comparing of data of different types of data sets. For example, when we are measuring that relative dispersion, simple we can compare also. We can compare who is the best, who is not best. For example, if you take into account in your class, if I want to say that you are the best, how I can say that on the basis of measuring that some values on the percentage, he has got more marks compared with the others. In that case, that the relative dispersion can also useful in comparison of data of different types. Then we will come to know that what are the absolute dispersions and what are the relative dispersion. So within the dispersion, there are so many statistical tools are there, which are defined. Next slide. See, MD, there are absolute dispersion and relative dispersion. So among these 9, there are other dispersions also there, but these are the basic learners also are the. So that's why I put it only which are more important for you, and also I put it that one also. The observed dispersion. For example, if you take what are the observed dispersion? The observed dispersion is nothing but range, quartile deviation. The quartile deviation is also called semi-entire quartile deviation or semi-entire quartile range. And third one, mean deviation. and fourth one standard deviation, and the fifth one variance. So what are the relative dispersions? The first one, relative or coefficient of range, or relative range, we can also call, or coefficient of range, coefficient of range. And the second one, coefficient of quartile deviation, coefficient of quartile deviation. And third one, coefficient of mean deviation, coefficient of mean deviation. And the fourth one, coefficient of variation, coefficient of variation. That is called, we can say COV and or CV and sometimes. See, when simple this kind of questions will arise in the entrance exams of the PG or SET or NET and other exams also. Sometime one or two times, so they ask the question: what are the absolute dispersions and what are the relative dispersions? So these five are the absolute dispersion, and these four are the relative dispersion. These are the mainly dispersions. Okay. See, here we'll come to know that what is the range and what is quartile deviation and what is mean deviation and what is standard deviation, what is variations. The next slide. Is it clear that? So simple. When somebody will ask that what are the relative dispersion and what are the absolute dispersion, we need to clear. We need to be clear. Okay. So absolute dispersion are the range, quartile deviation, mean deviation, standard deviation, variance. And the relative dispersion, there's a relative dispersion, coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, coefficient of variations. Simple in the relative dispersion, we will simple, you can understand when the coefficient will be added. That is called relative dispersion. Simple. That's the. So this question is asked in the use net exam also. What are the absolute dispersion and what are the relative dispersions? Then simple, we will come to know that the basic introduction of that this 6, the range. What is mean by range? How we can calculate? Or tomorrow we'll come to know that. But time is permitted to only 8 or 7 minutes are there. So meanwhile, we will discuss about the introduction of that this dispersions. Here the range, the first one. What is mean by range? When we are talking about in general terms, the range, when you are doing some when you are doing shopping, some people will ask that the shopkeeper they will ask that what is your range? Okay, in that call we can say that 600 to 800 if you want to purchase a shirt, or 3 to 500, like that. Simple in the terminology also same. Here the range is the highest value minus smallest value. That is called range. The range is called is the difference between highest value and smallest value, or largest value and smallest value. Simple. The range is the difference between highest value or largest value and smallest value. Is it clear that? Hello? Hello, dear students.
Yes, sir.
Yes, sir.
Yeah. Right. Then quartile deviation. Quartile deviation. See, is the quartile deviation nothing but how we can get the quartile? Nothing but is a deviation on the basis of the quartile. For example, what is meant by quartile? Can anybody can say that? What is meant by quartile? So I think most of the terms we will say that generally the most of the people will use the quarter. What is meant by quarter? Can anybody can say that? For example, see quartile deviation nothing but it is a 1/4 value. So how much is deviating within the range or within the data set? So the quartile deviation is a third quartile minus first quartile divided by 2. For example, if you take into account the quartile deviation, if you take 10 centimeters of a particular anything, for example, 10 centimeters of cloth. So what is the quartile deviation? The 1/3, that is the third quartile minus first quartile. Nothing but if you take 10 centimeters, the 7.5 is the third quartile. The first quartile is 2.5. 7.5 minus 2.5 divided by 2. How much you are going to get? 5 by 2, nothing but 2.5. That is the quartile deviation. Quartile deviation. Tomorrow we will come to know that how we can calculate the quartile deviation. And the mean deviation. Here the mean deviation is the sum of deviation divided by number of items. For example, when you calculate the mean, the average value, how much is deviating on the base of the midpoint. So basically the mean deviation will be calculated on the base of mean, median, modals. So on the base of our requirement, we will take that mean deviation. So generally most of the time we will take that from the mean, and when the particular person who can require from the median also, we can calculate median from the mean deviation from the median, and we can calculate the mean deviation from the mode also. So how we can calculate the median mean deviation? Nothing but the sum of deviation divided by the number of items. Number of items. Then a variance. So the variance is the sum of square deviation divided by the number of items. Or simple, the variance is the square of standard deviation. Variance is the square of standard deviation. Square of standard deviation. So standard deviation will you come to know. What is meant by standard deviation? The standard deviation is the square root of variation. Square root of variance. Whatever we get the variance, that should be square root. That is the square root. That symbol is will be there, square root. Like this. The square of standard, square of variance. That is the standard deviation. The basically the standard deviation which we will calculate for the how much is deviating from the mean value, which is a standard. And the last point, coefficient of variance. Coefficient of variance. So how we can calculate the coefficient of variation? So on the base of mean standard deviation by mean value. So if you want to show in the percentage term, we will calculate standard deviation by mean into 100. That is how we can get how much the coefficient of variation in the particular data set. So we will come to know that in the next class, with the practically we will come to know these things, how we can calculate the range and quartile deviation and mean deviation, variance and standard deviation, coefficient of variations. So here we have discussed about 6, but whereas come to the coefficient of range, here the coefficient of range is nothing but here there is a L minus S divided by L plus S. We can come to know that how much the range in the terms of percentage. For example, if you take the range, I told you that the range is highest value minus lowest value, or largest value minus smallest value. The largest form, when you're doing shopping, we can simply say that what is your they can ask, the shopkeeper will ask the question, what is your range to purchase a particular shirt or particular dress. We may say that 3 to 500 or 700 to 1000. That is the range is 300 only. 1000 minus 700. That highest value is 1000, lowest value is 700. Whatever we have given the data. Okay, 300 is the range. But if you want to know that how much the percentage is there, but when you come to the relative dispersion, then 1000 minus 700 divided by 1000 plus 700, how much? 1700. So we will get how much percentage is there? 17.6. That is called 300 by 700 is equal, we will get 0.176. So 0.176, nothing but 17.6% is the variation is there. And the quarter deviation, so we can calculate same. The quarter third by quarter third minus quarter one divided by quarter third by quarter one. Like that we can calculate. The mean deviation also same. And the coefficient of variation. So whatever we have explained about that variation also here, that is the mean deviation by standard deviation by mean, standard deviation by mean divided by into 100. Okay, is it clear now? If you have any doubt, you can ask me. Hello. Hello. If you have any doubt, you can ask me now. Regarding to the measures of dispersion. Do you have any doubt?
Sir, now only you said about that 17.6 some calculation you have said. No, sir, I didn't get you that. I didn't get that, sir.
So coefficient of range is nothing but see, the formula is L minus S divided by L plus S. Okay. So what I told you that the range is if you go to some shopping, you may say that your range is 700 to 1000. So what is the highest value? Whatever you say, highest value is 1000, lowest value is 700, right? So as per that range formula, here L coefficient of range L minus S divided by L plus S. L plus S. So I think if the time permits, I will show you that. See here the coefficient of range formula. See, highest value minus smallest value divided by largest value plus smallest value. So if you take here 1000 minus 700 and 1000 plus 700, how much? 1000 minus 700 is 300, and 1000 plus 300 divided by 1700. 300 by 1700, how much? 300 divided by 1700. How much will come? Only 0.76, 0.1, sorry, 0.176, 0.176. So in that case, you can say that the 17.6%.